Hello, we are going to deal with the solution of a problem regarding optimization, or it is either to maximize or to minimize. This problem is about optimization because of the word there. That's quite obvious, no? Again, words with similar meaning to words like maximum and minimum will be approached using the differentiation process. The specific principle behind would be maxima and minima. Alright, there is a given in that particular statement and it may be expressed in that manner, or yeah, either of the two ways will be possible, but in calculus, it is advisable that you minimize your number of variables. So I'd rather prefer the second option, wherein the only variable is x. Alright, this is quite a long story, but later on you will absorb this as simple as that, no? So that if you have two numbers, if one is x, the other would be y, but y would be 39 minus x, of course, because the sum of the two is 39. Or if you have the first number to be x, the second number is simply subtracting the first number from the sum of 39. So that if you're going to verify, add the two, the result should be 39, alright? Actually, there wasn't any mention who's first and who's second. Actually, in the problem, there's no mention of the two words, no? The word first and the word second. So I just used that to identify one from the other because it's very generic in the problem. It says find two numbers. So the best description would be the first number is the first number, and the next number is the second number. All right? Okay, and therefore our unknowns will be the two numbers, x, and the other one is 39 minus x instead of y. So we have just conserved our variables to just one, because remember, we cannot apply differentiation in optimization problems if a particular function is in terms of more than one variable. Right, the next question will be, which quantity is to be maximized? So you need to read the problem, understand it. What is to be set to maximum as stated in the problem? Yes, it is the product. And the product is described there as 1, the first number, that means times the square of the other number. Right, since we are asked to maximize that product, we are going to name the product by P. Then we will come up with two options. So these are the two options that I am talking about. It doesn't necessarily mean that when you say 1, no, product of 1, it's going to be the first. No, because the first may be chosen as either of the two, right? But in our case here, our first number is x. And it doesn't mean that that word 1 described in the product, that word 1 right there means the first. So it may be the first number as stated in option 1, or it may be the second number as stated in option number 2. Now, in terms of complexity, it's going to be very complex if you're going to deal with the derivative of this later on, rather than this one, because our base, remember, in differentiating a power, the last thing is to differentiate the base. So which is more simple, x as the base or 39 minus x as our base. In the duration of our solution, I am going to consider the second option, but you may double check, you may verify what I have just told you a while ago. Alright, so as I have said, option number 2 will be considered in the duration of this of the solution, and I can rewrite that further as a polynomial. I'd rather opt to differentiate a polynomial than its equivalent product. Alright, and that's going to be easier. At both are powers, both terms are powers, and just perform the power formula. See? So when you do option number 1, you will still have a derivative of the base, which is 39 minus x, isn't it? After differentiating, equate to 0, and you can see now the transformation. X becomes the value, the only value of x that would make p a maximum, because the expression just above it is still a general, any arbitrary value for x. It may take any value, but once equated to 0, then it means to say that we are now maximizing p, and the value of x would be the value, only one value for x that would make p a maximum. And you may rewrite that as well as factoring x for maximum p, which is common in both terms, at the right side of our function. And then if you're going to throw that to the left side, 0 over x sub maximum p will still give you 0. And this can be solved easily as, alright, that's it, simply substitution. So ladies and gentlemen, thank you for watching this video.